Hello guys, welcome back. This video will be a part of the 45 Golang project series playlist. So there are about 44 videos in that playlist now. So this will be the 45th one. So depending on when you're seeing this video, there will be many more, like there could be 50 or 60 projects in that playlist. So you just have to go to my YouTube channel, the playlist tab, and just search for this playlist, which is like either 45 or 60, depending on when you're seeing this. There are like, so many different videos in that playlist. Actually, let me show it to you. So you just have to go to Akhil Sharma, and here in my playlists, you will find this this one right now. There are 44 videos, Killer Golang projects. So this will be the 45th. And then maybe if you're watching this like many months down the line, there could be like 60 videos in this. So I'll keep continuing this playlist. And my goal is to have like a lot of projects so that you don't have to buy any course probably. And this could be like the one-stop solution for learning Golang, right? So we've covered so much in this playlist. There's Postgres, there's MongoDB, there's Redis, there's serverless stuff, there's AI also, there's scrapers, complete CRUD projects with authentication. There are blockchains. We did GraphQL recently, we did Echo, and today is all going to be about gRPC. So today's project, let me just put my phone on silent. So today's project is going to be all about gRPC. Now you will find resources about gRPC on the internet, but you won't find them with this type of clarity, because learning from somebody who's used it in production, learning it from somebody who uses it in his products or projects, on a daily basis. So with this level of clarity is something you won't get online. That's definitely. I mean, if you find on like YouTube, Udemy, or on websites, you won't find information with this level of clarity. The thing is, I wanted to show you like a full-blown big project with gRPC, but the thing is, I want to get started with a smaller project first, like a very small little project today, like a quick gRPC demo, because this technology can be slightly confusing to many people. So this is why I wanted to start with a small project. And again, I want to thank my intern Nikhil, who now helps me research and think of ideas of what to build. Because if it were left to me, I would end up building just really big projects, and viewers would have a lot of difficulty. But now I have somebody who can guide, or at least I can consult somebody. Okay, build like small projects, because he's a really young kid, right? He's a college kid, so I can ask him, should we build like small projects? So yeah, so we decided on building like a very small gRPC project now, and then building up on it. Like we'll build 2 more projects, will be like full-on projects in the future. All right. So kudos to Nikhil, my intern. All right. So now the videos that I make now, they require a lot more hard work, right? So we have to build the entire project, thinking of what all exact things that we'll cover, and from that angle we build the entire project, and then we push it on GitHub beforehand, so that you guys don't have any issues when you build it with me. In case you have any issues, you can always go to the GitHub code, and you can always like sort it out. Like the code is always with you. It's always available. And also we're trying to put these readme files where how to like start the project in case you wanted to. You could also have those details there. So just want to point out that the project is already there on GitHub. I didn't have this kind of a process or workflow before, because I just used to come online and build it with you guys. But now, like to enhance your viewer experience or whatever, we've started following this process where I just build it beforehand and then I come online. But because of this, I'm obviously not able to put as many videos as before. Like the frequency has definitely gone down, but then this ensures that you guys don't have any doubts after we're done, right? Because we've noticed that many young people also follow my channel. It's not just experienced developers, right? So I'm trying to make content for everybody. Anyhow, a lot of talk here. So this is the code. I'm Akhil Sharma 90 on GitHub. You can find a lot more stuff here for Rust, for Golang. So there's also a 50 Rust project playlist going on my channel. There's a lot of Rust, Golang stuff here. There's also stuff for Solana and Ethereum. So and it's all open source, free feel free to pick up anything, put it in your portfolio. My main agenda is you should use these projects and get a job if you can, and that's like the most important goal for me, because I don't do this for money. YouTube is not this is not my profession, or I'm not even an instructor. Actually, I'm just a developer, and I have my own companies, and I just do this for just sharing this with the community. That's it. And also for me to stay hands-on. That's about it. That's the whole agenda. So use these projects, put it in your portfolio, get jobs, and tag me or let me know if you get a job. That'll make me really happy, right? So that's my main agenda with this. All right. So by the way, I'm building this company called Armor. So in case you get time, you can check it out also. All right. So this was about the project. Now coming back to Grpc, which is today's topic. Right. Let me put this in full screen. So what is Grpc? Why do you want to learn it? Right. So I don't want to start coding directly because it is a different technology. It's different to what we've done. And there's a reason why I wanted to cover Grpc, because I want to start tackling some bigger topics. And for those to be able to tackle those topics, let me remove these headphones. To be able to tackle those topics, we need to know Grpc. Okay. So I'll talk about those as well. Now, this is what a regular architecture looks like, and this is what we have been doing, right? Even if we've been working with GraphQL, which we've been doing recently on my channel, even if we've done GraphQL, or even if we've done REST APIs or any SOAP APIs, whatever you've done in the past, what happens is you send a request to the server from the client, and the server sends you back a response, right? So this is what a client-server architecture, like request-response architecture, looks like with REST APIs or GraphQL or SOAP APIs, whatever you use. This is what you've been doing all this while. So it's synchronous in the sense you send a request and you wait for the response for that particular request. So it's synchronous. It's slow because you have to wait for the request to come back, and it's not scalable. It's not scalable in conditions where, let's say, you're using microservices or you're using a lot of different servers and a lot of different clients, right? So which request is going to which client, or which server is talking to which other server. So many servers are talking to each other. All of that stuff. A request response architecture is not very scalable because it leads to too many network requests, right? It's difficult to keep a track of all these requests as well. All right, so how do you scale it? One proposed way of scaling it is having remote procedure calls where the client can directly call functions from the client to the server. So that's why it's called as a remote, in the sense from a distance. Procedure calls in the sense you're calling a function at the server side directly. So it almost feels like the client and server are together, and the client is actually calling the functions from the server, right? So it's a very, very different approach. And instead of JSON, you use something called as protobuf, and the size of payloads is very small. And because the size of the payload is very small, it's a fraction of the size of a JSON object. So it accelerates communication between the client and server. Okay, so that's the main thing with RPCs, remote procedure calls, right? So the kind of explanation I'm going through here with you guys, it took me a while to put this board together, all right? And you don't find this kind of explanation even in paid courses that you'll purchase. You won't find this kind of explanation because, like I said, learning from a guy who's built stuff, use this in production, it's completely different. I mean, that's a whole different story, right? As opposed to learning from just an instructor whose job is to instruct, or just a YouTuber. All right. So that's the benefit you get when you work, like when you are with me, that whatever I do in the real world, I come and show it to you here. Okay. That's my main agenda, because when I was building stuff as a young kid, I didn't have mentors to look up to and people who had built stuff, right? There were many teachers and instructors and YouTubers, but not people who'd built stuff, right? And you get a different perspective from people who've built stuff. Anyhow, so I want to be that mentor, like your online mentor. Obviously, it's all async here because because I teach at scale on YouTube or whatever. But at least you have access to this kind of information. Anyhow, so how does that work? With being client and server, you have something called as streaming. Streaming is that there's a continuous flow of data, in the sense that there was a request and response earlier, but now you have a stream of data between the client and server. It's a continuous flow of data between them. All right. It's asynchronous in the sense client is not waiting for a message back from the server for a response back from the server. Okay, it can keep doing its own things and keep sending messages to the server and keeps getting back something from the server, but it's all asynchronous. It's extremely scalable because it's not a lot of network requests. It doesn't lead to a lot of network requests which are, everybody's waiting for everybody to get back some data. Nothing like that is happening here. And what's the use case? Why do I want to teach you this? Is because the reason I want to teach you this is because maybe you know that from the beginning of this channel, I've wanted to teach you guys microservices, but we have not been able to reach here because every time I want to teach you this stuff, I get so many queries about the basics, like in the sense, developers are not able to work with MongoDB or Postgres or all these databases with Golang and even with Grpc. So I want to tackle these technologies because you use all of these when you build a microservices architecture, right? Because you'll have different services, and then you'll have different microservices, and then you'll have like different database for each microservice. So something like that. You'd want to know Docker, a little bit of Docker. You'd want to know a little bit of different databases, how to connect them to Golang. You also want to know how to build CRUDs. You also want to know how to work with GraphQL, because when the users, they call the APIs, they can use GraphQL, but between the client and server and the servers themselves, we can have Grpc communication. So this is why I want to teach you Grpc. So the use cases are microservices, and the use cases are also blockchains. Now I want to cover more depth in blockchain. So we've done like 2-3 blockchain projects before in this series itself, in this playlist itself, but I want to do more. So blockchains, when the peers, they interact with each other, they don't make requests like regular request and response. They don't function like that because there's so many peers, so many nodes in a blockchain network, and they all have to communicate with each other. They have to gossip with each other to come to a consensus, right? So all of that doesn't happen with the request response architecture. That only happens with data streaming, and which needs a continuous flow of data between the peers or the nodes or the client and the servers, whatever. Okay. Now, if you've connected a client and a server together in Grpc, you can do like 4 types of communication between the client and server. Okay, you can have like regular request and response also. So it's not like once you integrate the Grpc or you've included Grpc in your project, you can't do regular request and response. You can do that, and that's called as a Unary API. So you can just call the client from the client to the server and just get a response back. That's it. It's called as a Unary API. So there is provision to do that. It's not like you sacrifice that, right, when you move to Grpc. The second thing that you do is called as server streaming. Okay, so what happens is the client makes a request, like a regular request to the server, but the server sends a stream back. Okay, there's like a sequence of messages. So you send a request and you get a sequence of messages, or like a complete stream back to the client. That's called a server streaming. Then you have client streaming, where the client sends a stream of messages to the server, and the server just sends a response back. That's it, right? So I'll just repeat again. The client in server-side streaming just sends a request that, hey, I want this data. Instead of sending just one big response object, you get a stream of data back, right? Similarly, with client streaming, the client, instead of just sending one simple request to the server, it sends a stream of requests to the server, like a stream of data to the server. Server can obviously segregate or like divide it, or disintegrate it, and then work with that. So, and then it can just send one response. But the most common use case, which you'll see very often, is the bi-directional streaming. Okay, this is where the client and server both communicate using streams. So the client sends a stream of messages to the server disintegrates that information, and then sends a stream of information back to the client. And this is not happening synchronously. It's not like the client has to first send the stream of messages and then only the client can send it. It's not like that. They can both do that in parallel. So there's information flowing from the client to the server, information flowing from the server to the client at the same time, like asynchronously. Okay, that's the beauty of Grpc. This is why everybody uses it. This is why it's worth like shifting to Grpc. And even though it's a stream, right? So we mentioned it's a stream of information between the client server. So even though it's a stream and not a queue, even though it's a stream, the order of the messages is preserved. Okay, I mean, you know which message came first, which message came second, third, fourth, and even though there's like not synchronous information and it's all async, but there is an awareness of the context and of the order of the messages that are being sent between the client and the server, right? So this is a great introduction. I mean, it's quite possible that you didn't get all of this in one go. Feel free to repeat the video, feel free to go over it again, okay, and like watch it like a couple of times, but you will definitely get it. This is the most this is the clearest and the simplest introduction to gRPC that you will find on the internet, for sure, okay? Because I've seen so many introductions and I've used it, like I said, in production, and I know how it works, like the underlying technology now, like really well. So the way I'm explaining it to you, just watch it a couple of times in case you didn't get it. I'm pretty sure you got it, like I'm pretty sure you understood what I'm trying to say, but in case you didn't get it, just go through it, right? So basically what you want to do is you want to work with scalability, because when you have microservices or blockchains, there's so much communications taking place. You don't want to have request response architecture because it's very synchronous. You have to wait. The size of the data packets is very big because of JSON. You want to switch to gRPC. That's the whole agenda. That's the whole point here. Okay, so this was the definition. Now I'll show you a quick demo. Yeah, so I wanted to show you a demo, but what happened was, instead of pressing F11, I pressed F7 by mistake. Like F11, I wanted to, exit the full screen and then like minimize it. But by mistake, I pressed F7. So whatever I was speaking, I think you couldn't hear after that. So I'm just starting another, like a recording stream here. All right. So basically what I want to do is I want to start a server on a separate terminal, which will be on the left. And I want to start a client on the separate terminal, which is on the right. So I'll show you 4 different examples. So in our code, we'll have 4 different examples, but right now I'm just showing you an example of bidirectional streaming, on the sense how bidirectional streaming takes place. So here we'll say go run star.go, in the sense starting all the Go files in the server folder, and in the client also I'll do the same, go run star.go. So here it says bidirectional streaming started. So it's sending a message, hello Akhil. Here it's saying got request with the name Akhil, Alice, Bob, and then bidirectional streaming finished from client and server side. Now the server is still on, but the client has stopped the bidirectional streaming. So this is bidirectional streaming from our side. So I'm just showing you just one example, but there will be 4 examples that we actually go through today. One will be obviously the Unary API for the request response. Then we'll have like server side streaming, client side streaming, and the bidirectional streaming, right? So we'll go through all the 4 examples. What we'll do now is I'll just park these. I think I'll just close this down. And what I'll do is I'll start a new project off with you guys. So I'll just go out of this. I'll say mkdir grpc demo and yt for YouTube, obviously for you guys, and I will cd into it. So I'll say demo and yt. Okay, and we'll clear this out now, and now is when we'll start. So first things first, you'll say go mod init /akhil grpc demo yt. Okay, check if the go mod was created. Open this up in VS Code. So there's only a go mod file here, right? But we're going to do a lot more. So we'll have a separate folder for our client, a separate folder for our server, and a separate folder for something called as proto, the proto buff that I was talking about before. Okay, in the client you'll have its own main.go file. So just remember, the client makes requests to the server. Server has its own main.go file. Okay, and then the proto is going to have its own greet.proto file. Now the greet.proto file is the file that you write everything in. So you define the remote procedure calls that will happen between the client and the server. So you'll define all the remote procedure calls here in the greet.proto file. But the actual code that's required for the interactions to happen between client and server, that actual code will be in something called as the pb.go files, and those files will be generated for you, right? So there'll be a pb.go file, like a greet.pb.go file, because we have greet.proto, and there will be a greet_grpc.pb.go file, right? So there will be two files. They will be generated automatically for us. So it's very similar to GraphQL, like how in GraphQL just create the schema, everything else is created for you. Here you do have to do a little more work, because you have to create the actual client and server functions, and you actually have to write the report, like define the RPC calls here. But the actual pb.go files, like for the grpc and for the regular pb.go files, those are created for you, right, with the code gen. So what you want to do here is the first thing, the best thing to do is to start off your greet.proto file. Okay, so the way you do it is you say syntax, and we're working with proto 3. Okay, now you'll see that my proto file is in a different color. It's because I'm using an extension for proto. Let me show you which one. I'm using this one, like I think one of these, like VS Code Proto 3 support. Yeah, sorry, this one, VS Code Proto 3 support. So this just colors your code so that you can it just becomes a little more readable. Otherwise, everything will be in white, because VS Code on its own doesn't recognize Proto. The important thing here is this option go package, right? You want to get this right, because the files that will get created in this link, right, in this place. So the two ways that you'll usually see on the internet to do this, one is that they will write the name of the package here, like this whole thing here, out here, and then when they'll run it, you'll have to change the CLI command a little bit, and then the files will be generated in your proto folder. But the easiest way to do it, especially if you're a beginner, is just leave it like this. Just have like ./proto, because this is where those files will get generated. Okay, so you don't want to mess around with it too much. What is this package called? Just like on all Golang files, you have a package, right? So here it's going to be called greet service package, and then in your service you'll have something called as the greet service. Now this function, by the way, all the things that you're seeing here are going to be very common, in the sense you will be using this kind of a format very often in the future in all of your future projects. So it's not like something that you're doing for the first time, or you're doing it only once and everything else is going to look very different. But Proto is very, very opinionated, in the sense the way you write the code right now today in this project is going to look very similar to any project that you find on the internet, on GitHub, or that you end up building, or you find on YouTube or Udemy. It's going to be look very, very similar to this. Okay, so you usually have like a service here, which could be called anything else. We're calling it greet service, and this is what it is going to have my RPCs, right? So let's say the first RPC is say hello. This is my Unary RPC. I told you there will be 4 types of RPC calls: Unary API, which is just a request response, server streaming, client streaming, and bidirectional streaming, right? So first we're working with this one. So here it takes in no parameters. It's just a request and response. It returns a hello response, let's say. Okay, now hello response is something that we have not defined yet. So let's define these messages. So no param is also a message that we need to define, and we also need to define a message called hello response. Okay, what does it look like? It just looks like this. It has a message. All right, this is my say hello, right? Then I will have an RPC for server side streaming. Like I said, there are 4 types, right? The second is server side streaming, and I'm going to stream I'm going to pass a names list to. So if you remember what server side streaming is, the client sends a request to the server sends back a stream. So the request that I want to send is called names list. That's the request, that's the object that I'll send in the request. But what I'll get back is a hello response, but it's actually a stream. So whenever I write stream here, right, has to be with a small s, make sure of that. So whenever I write stream here, it says it's going to like send me back a stream, right? So I hope everything is very clear. I'm taking a lot of time to explain everything, taking a lot of time to go really slow, explaining every single line to you, right? Because gRPC is something that's going to be very fundamental, very important for all the microservices and blockchains, like the bigger blockchain projects that we'll do in the future. It's going to be very, very fundamental. So RPC, say hello. Then you have something called as client streaming. Like I said, the third one, it's going to take in a stream, right? So from the client, a stream goes to the server, but the server just responds with a simple response, which is called as a message list. Now, please understand, it doesn't say stream here, but it says stream here. So whenever it says stream, that's the type of streaming it is. So it's getting a stream back from the server, so it's a server-side streaming. It's sending a stream from the client to the server, so it's a client-side streaming, and from server it doesn't get back like a stream. It just gets back a list of the messages. Okay. Then you'll have, say, hello bi-directional streaming, right? So from both sides, streaming from both sides, so it accepts a stream and also returns a stream. Okay, hello request and hello response. Like I said, the fourth is the one that you'll see being used very, very commonly everywhere. Now, we've defined hello response, but we've not defined hello request messages list, right? We've not defined that. So let's do that. So, and also we've not defined the names list. Okay. So you got to define all of that. So we'll say message hello request out here. We'll say message hello request out here. And we'll say string name is equal to 1. Okay. So we'll send a name, get a message back. So send a name in the request, get a message back in the response. Now, what's the name list? The name list is actually repeated string names equal to 1. Okay. And what's the message list? Messages list. It's actually again repeated string messages equal to 1. And that is it. You see these 32 lines of code. This is it. You don't have to do anything else with Proto. All right, nothing else. So the spelling, I need to fix the spelling here, no param. The file, you don't see any errors here, and you don't see any complexity here. And by the way, guys, this is it. This is your Proto file. You don't have to do anything else here. No extra work required, no more work required. This is it. All right. For the time being, I'll just write package main here, okay, so that the errors go away. Write package main here, okay. So just once more, I'll just repeat it once more. 32 lines of code, which even have like these spaces, but this is it. This is all that's required to start off these 4 different types of RPC calls between the client and server. Don't have to do anything else. This is it. All right. Now all we have to do is use the Proto file and generate some code. Like I said, the pb.go file and the pb.grpc.go file. That's what we want to generate now. Okay. So what do you do? You say Proto C, right? So this also means when I'm writing Proto C here, this also means that you need to have Proto C, which is the Proto compiler in your system, right? So a great way to do it is using apt install for Ubuntu. For Mac, you have Homebrew. For Windows, you have Choco, which is a package manager, or just the direct like regular Windows install also will work. In case you want like the best and the freshest version of gRPC, which like if you have 3.12, 3.15, I think things will work perfectly fine. But if you need like 3.19 or 3.2021, I think 3.21.12 is the latest one right now. So usually people building projects right now in 2022, you'll see them use 3.19 and above. So in case you want to use any of those, like the recent ones, then you have to actually, let me show you if I have it here. So grpc install Yeah, so you need these two if again, I think it's optional. You don't have to have them, but just run these two commands anyways in the project folder that you're in. Just run these two commands. Go install. And like I did, I just went to grpc.io/docs/languages, or on Google, I just said go grpc golang install, and you'll come to this link. These are, again, like I said, optional, but just have them if you want. Just run these two commands. And you might want to do this also. Sometimes the proto-c command that I'm about to show you might not work sometimes. So you want to do that. You want to do this also sometimes, right? So in case you get any errors, make sure you run this also in your terminal. Okay. And if your go path is not set properly, for example, in my case, I'm using WSL2, so it keeps getting reset. So if in my case, every time I'm on my terminal, every time I open up a new terminal, I do run this command actually to make sure things work. But you don't have to do it. It's completely optional. You can do it if you want, skip it if you want. But if you're getting an error, like I said, you might want to do this. And you might want to run these two commands also, again optional. But the one thing that you definitely need is this. Where is the proto buffer compiler installation? This is the one you need. Okay, so like I said, the one way to do it is apt install Mac OS. You do homebrew, but if you want a particular version, like the latest version, and this is also how I have done it, is that you create this variable called pbrel, and you fill that up with the protocol buffers pro buff releases link, and then you make a call to that link pbrel. After that, you have download, and the version you can mention a specific version like 3.19, or let me zoom this in case you're watching this on iPad or phone or whatever. Sometimes people watch it on very small screens, like a 12-inch, 13-inch, 14-inch screen. Well, I create these videos on a huge screen, so that's a discrepancy sometimes. So I do have now a big font in all of my VS Code and my terminal and everything, but sometimes when I'm browsing the internet, maybe you'll find that it's really small. But I apologize for that in case you have those issues here. But yeah, so what you want to do is here you replace this with 3.19.4 or any other specific version that you want, and then you just unzip it. Sometimes you don't have unzip on your system, so you want to install the unzip package with apt installed, right? So many people have that issue. So you get that, and then you export your environment variable like I showed you, and then everything should work perfectly fine. What you want to do is you want to run proto-c -- version. I'll just zoom in again, proto-c -- version. This is the one that should work perfectly fine. All right, this command should work perfectly fine, and then you're good to go. Let me show you how that looks. So if I say proto-c -- version, it says 3.19.4, so I'm using 3.19.4. You could be using higher than this, or even 3.12, 3.15 should be stable. I don't think they will lead to any problems. But just make sure if you can make sure, just have this, and make sure this command is definitely working, right? So once we have that, we can start building our project. Now that we have live proto-c, what I want you to do is I wanted to say proto-c --go_out is equal to dot. So it's not got, sorry, it's go_out. Okay, and then you'll say --go grpc out is equal to dot. All right, so what's happening here is I told you there'll be two files that'll be created. One will be the go.pb, the other will be the go grpc.pb file. Okay, so we want these two files to be created in this location, which is the current location, and we'll say the proto file is in the proto folder /greet.proto. So greet.proto is the name of our file. It's in the proto folder, and depending on this, as in the Go package, this is where the files will be created, right? So we will hit enter, and now it doesn't give out any output, right? So that's what you want. That's the ideal state actually. And let me minimize this. So here you'll see that two files have been created, pb.go and grpc pb.go. Okay, again let me show you this command. go out, created at the current directory, grpc out, created at the current directory, and proto/greet.proto is where you you have the greet.proto file. And because of that, because it will go and read the greet.proto file and it'll see that the place where it's supposed to create these two files is this, so it'll create the output there exactly. Okay, now what you'll do is we'll say go mod tidy, because we can see in our pb.go and pb grpc go file that some of the packages are missing, and that's why it's giving us these red line errors, and now they've all gone away. So that's a great place to be. Okay, so you have your main client, you have your main server, but we have not written any code there yet, which is not ideal. We should be writing some code there. So what we'll say is in our server we'll create a server. Okay, so firstly I'll define a port on which the server will run. So I'll say it's port 8080. Okay, then I'll have my func main here, my main function. In my func main I will create a listener. So I'll say list is equal to net.listen TCP port, port. So I'll save and I'll get the net package here. Getting 2 lines here because I've not handled the error, and I've also not decided what to do with this at the moment. So first let's handle the error. So if error not equal to nil, I'll say log.fatalf failed to start the server error, print out the error. I don't have the log package also, so I'll just say Control S, it'll get the log package for me. Okay, so I have the port, but I want to create the grpc server. So to create a grpc server, we'll say grpc.new server. Okay, I don't have the grpc package, so let me get that. So it's Google remote protocol calling. Okay, so that's remote procedure calling, sorry, it's for Google. So it's grpc.new server, and now I'll say if error equal to grpc server dot serve, and we'll pass the port there, lis. So let's pass the port there, lis, and error, handle the error, log.fatalf failed to start %v, error. Okay, now that's not all, right? That's not all. We also need to say pb, right? Pb means this the proto stuff here, dot register greet service server, right? So if you remember, we created a greet service and we have all these functions there, but to create the server with context to the greet service, so we'll say pb.register greet server, and here we'll pass our grpc server comma and %hello server. Okay, so let's worry about hello server in a while. For now, just say log printf and server started at %v, and you listen on this address. So like I'm always writing it as list, not list. So it's list basically. Now hello server, right? So hello server is something you'll come and create out here. So you'll say type hello server. Sorry, my door is creating a lot of noise. I'll fix it in a while. It's very windy today, so that's why my door is all right, anyhow, so here you're supposed to say pb dot greet service server. Okay, now you don't have pb, so pb is essentially your protobuf. So what you'll say is define this as pb, and we'll say it's github.com/akhil/ basically you want to get it from here, right, from your go.mod/grpc demo yt. So we'll say grpc demo yt/proto. So that's pb, and now you have everything sorted here in your main.go file for server. Now this is all the code you need to start off your server on port 8080. So I'll take you through it again. Firstly, you need pb. pb is basically your proto, all your files related to proto stuff, including the files that were just created, right? So if you can see all of this file, so much data was created for you, so much code has been created for you guys, right? As you can see, there's also grpc, and everything basically relates to the proto that we created. So you see here, say hello server streaming, client streaming, bidirectional streaming. These are all created from our service, greet service, right? So this is why we also want to talk about our greet service. So we start like a server which is capable of running the greet service basically. So that's why our server says register greet service server, and we pass our grpc server there, which is created with the help of the grpc package, the new server function, and you're listening on port 8080, and you send here your hello server, which is basically greet service server, right? It helps you to register that service. Then you start your server, and then you serve on that address, and then if there's a problem, it'll say failed to start. So that's it. That's your server code. Now the client, as we know, client is supposed to make requests to the server, okay? But we won't be making secure requests. We'll be making not secure requests. So firstly, let's start with the same thing. So I told you that it's almost like the client is making functional request on the server side. So that means they both need to be interacting on the same port. I'll define the port here again as 8080. Okay, so that's our constant, equal to 8080. And I'll have another function here called funcMain, which will be my client. So I have to start off a client here. So I'll say connection error grpc.dial. Now, how do you make a HTTP request? We use some functions in the HTTP package and then make a request to the server, right? To a website, to a server. That's how you make client requests or server requests from a client in Golang. The concept is very similar with grpc as well. So you have a Golang program which is going to run off as a client, and the client is going to make requests to a server. So that's why you use the grpc.dial function here. So here you'll say localhost plus port comma grpc dot with transport credentials, and here I'll say insecure. Like I said, we're not using any secure credentials, so we'll say dot new credentials. Okay, and this is it. So I'll just keep this open for a while so that you can see it in case you didn't see it. This localhost plus port. So localhost port basically is 8080 here, and not using any secure credentials, insecure credentials. Now, obviously I'm getting red lines here because I want to handle the error and do something about the connection variable that I just created. So I'll handle the error first. I'll say log.fatalf did not connect, error. Then I want to have this connection closing, and I want to defer it. So we want to do a lot of stuff from the client to the server, but at the end, when everything is over, we want to close the connection between the client and the server, right? That's how you see that, right? When I showed you the demo about the client and the server kept running with the client closed down after making the requests. So that's what's happening. So at the end, when everything is done, you want to close the connection from the client to the server. So that's why I've said defer. Defer basically ensures that this function runs at the very end of the execution. pb.new greet service client, and you send connection here. You have names equal to ampersand pb.names list, and names. So I want to send some names here. Let's say Akhil, and I'll use standard blockchain names, Alice and Bob. So whenever you configure a blockchain or work with a new blockchain, you have to configure these addresses like Alice, Bob, and all that. So I'm just keeping those as the standard addresses here. And now the first function that I have is called say hello and client. Okay, so the client being this. I'll save it. Hopefully I get all of these. And I'll comment this out for now. Okay. And we'll have to obviously create this function in one of the different files. But now I need pb here again. So firstly, what I'll do is I'll say pb and then github.com/Akhil/grpc demo yt/photo. Okay, and now it can't find this function. That's understandable because we've not created that function yet, and now it's not, we don't have any use for the client, so that's why it's creating a problem. So let's keep this out, commented out for now. Okay, everything will make a lot more sense in a while. So we have a basic server code ready, and we have a basic client ready, but it doesn't do anything. Like it'll just start off the server and the client, but there's no point of having this. There's no point as of now. What you actually want to do is you want to start having firstly our Unary API, then our client server, our server stream, client streaming, server streaming, and bi-directional streaming. So we want to demonstrate all of those things. So what I'll do is I'll create a new file here called as unary.go for my Unary API. Okay, and here I'll say that this also belongs to package main. So function hello server. Now this is a method, that means the method for hello server struct, and the function is called say hello, right? So I'm demonstrating the very first function. It takes in context dot context comma request, takes in a request pb dot no param, and it returns a response. So I told you that Unary API is the very basic straightforward API where you just send a request, you get a response back. So here you'll say pb dot hello response comma error, you get that. Okay, and from here you want to say return ampersand pb dot hello response, and you want to say message hello comma nil. Now again you need pb here. So it did get context for me, but I also need pb here. Not sure why it's not able to get pb for me. I need it again. I'll say pb github.com. Actually I'll just copy the same thing from here, wherever I have it here. Yeah, just copy and paste this. Okay, sorry, these are supposed to be round brackets. Okay, so this is your Unary server function, which is called as say hello. Now from my client, I want to call that function, like I said, call say hello. And that function also needs to be there in my client side. So I'll say unary.go. Okay, I'll create a new file for it. Now I could have done everything in one single file, but I want to demonstrate everything to you, so that's why I'm not doing it. So here is my function called call say hello, right? The one that I'm calling from my main function call say hello is actually here in the unary.go file. So here I'll say client pb dot greet service client, and here I'll say context cancel context dot with timeout context dot background comma the time package. So we definitely need the time package here. Okay, so firstly you obviously need pb again, so I will copy pb from here and paste it here. Okay, now let's do something about the context and cancel. So firstly, I'll say deferred cancel. That cancel is taken care of. And then I'll say client dot say hello, pass context, pb dot no params, and I'll get back my response here, or I'll get back an error. And I should be able to handle both. So if there's an error, I'll say if error is not equal to nil, log dot fatal f could not breathe, comma error. Okay, and log dot print f percentage s, comma response dot message. What you actually want to do is you basically want to print the response that you get back. So like I said, client, we're demonstrating a Unary API call. So that, like I said, there are 4 types of RPC calls we've defined in our proto, right? There's just a regular Unary call, which takes in no params and returns a response. Then we'll be working with server streaming, client streaming, bidirectional streaming. But right now we just worried about this one, which takes in a param and with no param and then returns a response, right? We've defined what no param looks like. It's nothing basically. Hello response looks like this. Now what that means is from our client, we'll have to create the ability to be able to call our server. The server looks like this. Server is basically server grpc.server running on port 8080. The client uses the grpc.dial function to call the server. Okay. Now, the exact specifications of the Unary API are mentioned in the unary.go file in server side and unary.go file in the client side. The unary.go file in server side has this function called say hello, which is supposed, when you call this function, it's supposed to return a message called hello, right? So this is the response, right? Remember, this is the response, not the stream. It's just the response, just like a regular API would work. And here, when you're calling that function, client.say hello, you're sending a request, which is no param request, and you're also passing the context, but you expect some response back. Once you get the response back, you just want to print out the response in the client side. And the client terminal, when we'll run it, you'll see it there. Now this all sounds really good. Should we try to run something here? We can try to run the server and the client just to be safe, just to see that if everything is working fine. Now there could be errors, there could be issues because the code is not complete yet, and that's okay. If there are issues, we'll just move forward. We won't try to fix the issues because there's so much code to be done, and then obviously we know that in the end everything will work together. But right now everything is incomplete. We'll still try to see if server and client works. If it doesn't work, even if it doesn't work, we'll just go ahead, right? So cd server, and here you have cd, and I'll just find my project grpc demo YT, okay, and cd client. Okay, so here I'll say go run star.go, and here I'll say go run star.go. But right now, like as you know, nothing is happening here. So what we can do is, if you want something to happen, we can actually call this function. So let's create the client, and let's call say hello function, which is the our Unary API, right? So it just removed this by mistake because I had commented this out, so it just removed the PB for me. So I have to bring it back again, and I will stop this just to be safe. Start it here, right? So I got hello back. So like I said, we pass something from the client. This is the client terminal, this is the server terminal. So we pass something from the client to the server, which is that no param request. So make a request, we get a response back, the response being hello. So if you look at the code, the response that we get back is simply hello. Now when we get the response back in the client, we print that response. So this is exactly what we expected. We expected hello to be printed in the client terminal. So everything works exactly the way we want it to work. And till now, we have demonstrated how to start a client server, how to start a client, how to start a server, and how to make Unary API calls after everything, like obviously integrating everything with Grpc. Okay, so that's a great milestone, and now we can focus on the rest of the stuff. Now that we've done Unary stuff, we can now take care of the server streaming. So let's come here, okay, and uncomment this out. Okay, uncomment this and comment this out because this was our Unary API, and let's create call say hello server stream. So we want to see server stream right now. Server stream basically will have the ability for the client to just make a request to the server, but the server will stream something back to the client. That's what we want to build right now. Okay, so that means I first need a function in my server side. So what I'll do is I will come here and I will create a file called server_stream.go, and this again belongs to package main, and obviously I'll need to import some stuff which we'll work with in a second, but most importantly I need a method. So I'll say hello server, say hello server streaming. So this is my function, takes in a request, so it's pb.nameslist, and so we'll say stream pb.greet service underscore say hello server streaming server, and can't send back an error. Okay, so here we'll say log.printf got request with names. Right, so we want to send a list of names as a request. So we'll print that out at the server in the server terminal. So we'll say that hey, from the client, this is the request we received, and it's basically a list name right here. As you can see, it's a list name, which is this Akhil, Alice, Bob, and that's the thing that we want to print out at our server. And for the names, we'll range over the request names. So the collection of names that we receive from the request, we'll range over them, and we'll say pb.helloResponse, and we'll say message, we'll return a message hello plus name for each of the names. Now let's handle, so we'll say stream, so we'll use a stream function and we'll send the response as a stream. Okay, and we'll handle the error. So we'll say if error is not equal to null, return error. So we're getting a request in terms of a names list. We go over the name list being what we are sending from here. This is the name list. We'll send this that as request, like I said, as name list, and we'll go over the names in that request that we're receiving, and we'll create a nice little response which is of type hello response. Hello response is something we have defined here, hello response. So we'll create a hello response with message which will have hello plus the name of the people from the list one by one, and we want to send all of this response as a stream, as it's getting created as a stream to the client. So that's why we use the stream.send method, and we want to have some delay, so we'll say 2 seconds delay. Okay, we want to simulate with the help of this delay of how an actual big function will look like and how actual streaming will happen. Otherwise, if we don't put this delay, then everything will just happen suddenly and everything will close. We want to simulate how it looks like in the real world when we'll actually have like really big amount of data streaming between the client and the server. Grpc demo id/proto. Okay, so this is your server streaming function on the server side. Oh, so now we also need this function that will call that function. So we need that function that's call say hello server stream. So say hello server stream is what we just created here. Say hello server stream, right? So it won't be call, it'll be just say hello server streaming, right? And this will be call say hello server stream. Okay, say hello server stream. Yeah, so this function doesn't exist right now. So what we'll do is now we will create that function. So let's say it is server underscore stream dot go. So now we want to create the ability to be able to call the server from our client, send a request with the names, get back the response as a stream, and print it out. Very straightforward, right? Very, very straightforward. At least that's how it seems from my explanation. Let's see what all we need to do here. So we'll have package main. We'll have to import some things, and we'll create a function called say hello server stream, which is this function which we have defined here. This function. Okay. All right. Takes in a client pb.greet service client, comma names, which is star pb.names list. Okay. So log.printf, first you want to indicate that the streaming has started. Awesome. Then you want to say the client.say hello server streaming, right? Context dot will be all small. Context dot background, comma names, and you want to say stream, comma error. Error is not equal to nil. Log dot fatal f could not send names, comma error. Okay. So you were able to you basically want to call the server function from here, from using your client. Okay. Calling the say hello server streaming function. And you know that you send a request, but you get back a stream from the server. You know that. So now we want to be able to process that stream at the client side and print it out, right? So how do you do that? So you'll say for message, comma error equal to stream dot receive. So whatever stream that we have received, and the client makes a request to the server sends back a stream. The client now needs to process that stream, so it's going to go through that stream of messages that's received, and then wants to print it out, and then it'll check if there's an end of file. Then you want to break, right? This error could be there, or if error, whatever other error is there, if error is not equal to nil, you want to essentially log.fatal f error while streaming %v error. Then here you want to log println message and log.printf streaming finished. Okay, right? So here you get stream, you've received the stream, right? You check for end of file, check for other errors, and you print out the message that received in the stream, right? Stream.receive, which is the message. Print it out, you go through that, print out the entire stream that you've received. And then you say streaming finished, just like you had printed streaming started. So start streaming and then stop streaming. So that's your server stream, and in your main.go for client, that's the function right now, right? So the Unary one, I've commented it out, the Unary function, but server stream is open right now, and we want to test out our server streaming. So what you can do is we can open up our terminals again, and I will say again, go run star.go here in the server side, go run. Right, so streaming started, like we said that we'll print out streaming started, and then here it's saying you got the request with names. So first we send a request with Akhil, Alice, and Bob. We send all of these requests, right? And here we want to first print the message Akhil, hello Akhil, and then we want to press hello Bob, and then we want to say streaming finished. Okay, so server got a request with the names from the server, from the client. The client got back a stream, started the streaming, and streaming finished, and then it printed out every single message, right? So now you've seen it in demo what it looks like. I'll go through the code once again. Server side, you got the request with the names. That's what we printed out, the entire list of the names that we received from the client. And then we created a nice little response for it. We sent that response as a stream. We had a delay for 2 seconds. And from our client side, we called that function. We started the streaming, finished the streaming, and in between, we printed out all of the stream that we received from the server. So that's your server streaming. Now client streaming, right? So from the next thing that we'll be doing is client streaming, where the client streams some data to the server. Server sends back a request. That is it. Server just sends back a request. So the client's job is to stream, right? All right, guys. So now we have to work with client streaming. So I'll go to my server and I will create clientstream.go. Okay, at the server side. So the client will stream something to the server, and the server just has to send a response. So that's what we want to build right now. Okay, this belongs to package main. Sorry. We'll also be importing some things here, as we already know. Then comes the function, and the function will be set up in the same way. It will be a method actually. It's going to be called say hello server. Instead of server, you'll just say client streaming. It accepts a stream. So instead of server, you say client everywhere. So it's the client streaming server. Okay. So firstly, let's define a variable called messages of, and it'll be a collection of string. Okay, that will be a slice basically. So we know that the server is going to receive a stream because the client is, this is for client streaming, right? So the client is going to stream and it's going to send a stream to the server. The server has to accept that stream and process it. How do you process it? You say stream dot receive, just like we did earlier, but at the client side. And we know that this is coming in the request. The stream is coming in the request. So we'll use a request variable so that things are more consistent. And then we'll do the regular stuff, whenever we work with streams, which is checking for end of file and close pb dot messages lists and messages. Okay, so we don't have IO and PB at the moment. It was able to get us IO, but it didn't get us PB, so I'll get that as well and put these two in a bracket, which get removed. Yeah. So now it's formatted. All right. If any error apart from end of file, we can check for, or we can just say error is not equal to nil, and we'll just return the error. Okay. Then you say log.printf and just want to print out the request. So it's a got request with names, with name. Okay, it'll print it out one by one because we are in a for loop. So it'll print it out one by one, and we'll say comma request.name. And our messages variable, which is actually a collection, will keep appending the message to it. So we'll say messages and hello comma request.name. So whatever was there in the messages, it appended hello with and the request name. So request is basically this, and there will be multiple names in that, so that you can access that with the help of request.name. And request will basically be the stream that we just received. Okay. Save it. I'll get the log package here, and this is it. Everything is done. So this is our client stream, but for the what do you call it, for the server side. Now we will do the same thing at the client side as well. So we'll say client underscore stream.go. Again, it'll be package main, and then you'll import something, obviously. Okay. For importing, I know I need the PB thing, so I'll get it here, because every time it creates a lot of problems. So here the function is going to be called call say hello but client stream. Greet service client, comma names, and then pb dot names list. Okay. So firstly, you want to say client streaming started, right? So when you start the streaming from the client side to the server side, you want to send the list of names as a stream. So first you'll say streaming has started, then you say client dot say hello client streaming context at background stream comma error. Then you'll handle this error out here, right here. So it's error is not equal to nil. Could not send names. Now you want to go through all the names, the list of all the names, and create the request. Okay, so how you'll do that, you'll say range over the names dot names. Okay, and here you'll say for underscore comma name. So you'll get access to all of the names one by one in the variable called name, and you'll format your request. You'll say pb dot hello request. We already know that this is a struct hello request, and it basically, that struct has a name as a field. So if you'll say if error is equal to stream dot send request. So you've created your request one by one with the name, and then you want to send it as a stream. So to send it as a stream, you use the stream dot send function, and you send in the request there. Handle the error here itself. Say error while sending %v comma error. Okay. And here you'll say sent the request with name %s comma name. Time.sleep to second. So I need the time package also. I'll get the time package, log, context, all of those things. Okay. Finally, you'll say stream dot close and receive. You'll get a response from the server. To read the response, you need to the stream that you're sending to the server. You need to close that stream, and you need to receive the response. Okay. So it's a log.printf client streaming finished, and if error is not equal to nil, log.fatalf error while receiving. That means you didn't receive the response at the end. Printf %v response dot messages. So whatever response did you got from the server, you want to print out all those messages here. Okay, so that is what you will do. Okay, so the code seems to be okay for me for now. First things first, you need the function here. So we'll say call, say hello client stream, and pass the client and names here. And since I know that I'll also have a bi-directional streaming function here, so I'll just add it here right now. Bi-directional stream, pass the client and names there, and I'll keep this commented out for now. Okay, I'll keep this also because we want to test this function call say hello client stream is this one, right? So we have to mention it here in our main.go because that's the function we want to call, and the function already exists here. Okay, now what we'll do is we'll go back to our terminal, and we'll like I said, I export my path usually, so I'll just copy and paste this command here. Just a second. And I'm going to say proto. This is the same proto-c command to create the out and grpc like pb, those files. So whenever we add some new functions, we need to just create those, just need to add those, like ensure that this is like updated, both these files are updated or not. And even after doing those two steps, which is adding the function here in main.go and also running that proto-c command to generate the latest pb.go and grpc.pb.go files, even after that, if you're getting these red squiggly lines, that means something is wrong, right? So we need to figure it out what's wrong. Now, one possible thing is that the name of this function that I'm calling from pb function, sorry, the struct or interface that I'm calling from pb is not correct. So if I go here and if I search for say client hello streaming server, it says that it should be the h should be small right here. So here if I go and make the h smaller, so that takes care of the problem. And here say hello client streaming, right? This one, I'll just go and search that also here. Here also it seems like the h should be small, and that also takes care of the issue for me. Okay, now because this code is generated automatically, you need to make, like, you need to just check this like once a while or something, just to be sure that you're calling the right functions in those auto-generated files. Now the time has come for us to try out the code. So I have my server here, and I'll clear everything out, and I'll create one more terminal, and I will cd dev stuff. I keep forgetting where I've kept these projects sometimes. Now in my client, so I'll first start my server, right? So just to make sure which function is selected right now, the function that's selected is the hello client stream. That's the one that I want to test, right? The client stream is what I want to test. Let's see if everything works perfectly fine. So here I'll say go run star.go. Here I'll say go run star.go. Right, so I get some errors here in the server side. Some errors in the server side, but in the client side, client start streaming started, sent the request with the name Akhil, error while sending EOF. Okay, so seems like something went wrong. Now we'll have to figure out what went wrong, and we'll have to fix it. So now that we're getting an error, I know what the issue is actually. So what happened here in the proto file was that everything else was say hello like with a capital H. Here by mistake I put a small h, and because of that all the files went out of whack. And even though we're calling, like we changed this to call this function, but they have interdependencies between them, and that's why there are these issues. All right, so it's best to change the proto file and put the capital H there so that everybody is consistent. And now we will recreate the file. So when we recreate it, let me minimize all of this. When we recreate this, what happens is this goes out of whack, which is perfect, because which is what we expect, and now everything makes sense. It's all making sense now because there's interdependencies between those functions and everything. Now when we try running this program, hopefully everything should work out perfectly. So I will enter into server, okay, and here I am already into client. So here I'll say go run star.go, and here we'll again say go run star.go. So client side streaming started. You're sending request with Akhil, Alice. There's a 2-second delay, right? So Bob has already come here, but here I think we'll have to just refresh, right? And then client streaming finished, and then you got the entire response back. Hello Akhil, hello Alice, hello Bob. Got the entire response back, and also you've started and finished the streaming, sent it to the server, and server sent us back the response, right? So client also works out perfectly fine for us. Now I'll just stop this server also. Just remember to stop the server with Control-C, not with Control-Z, because what happens is sometimes it doesn't free up your port when you press Control-Z. So Control-C is more of a better option. Anyhow, so I've been shooting for quite some time. All right. So the next thing that we have to do is the bidirectional streaming. Okay. So we can start from the server side. So we'll say bi stream.go. I'll close off everything else. And just make sure you have the bidirectional stream function uncommented. So here we'll say package main. Now this is the last thing. So bidirectional stream is the last thing we want to demonstrate. So I'm happy because now I'll get to take a break after this. Shooting is like shooting these videos is a lot of work. So it's great that I'll get to take a break after this. So it's function, again it's a method, sorry. So s hello server, and then you want to say hello bidirectional streaming. So as you know, it takes in stream pb.greet service, and I've already shown you. In case you're confused about these interfaces, you can always go to the grpc.pb.go file and then just pick it up from there. Hello bidirectional streaming server. You may get an error back. It doesn't know what PB is right now. That's okay. So now the main thing right now is both sides are responsible for streaming, right? And both sides are responsible for like sending the stream and also receiving the stream. So we want to have stream.receive and stream.send functions implemented at both the sides, both the server and the client. And here we'll say for, and firstly, because it's a server, it'll be receiving a stream. So stream.receive, first will receive a stream, right? So the first stream will receive will be a request. So we'll use the request variable. Standard stuff, check for end of file, return nil, handle the error. If error is not equal to nil, return error. Okay, still we don't have PB here. I'll go and get it from here. Okay, so log.printf got request with name %v comma request.name. Right, and response will be pb.hello response, which is our struct, and message. We'll add a hello there, and then we'll basically add a hello to the request.name, right? So we get a request as a stream, and the request is going to have names. So that's why if we're running a for loop, we can go through the request names one by one and keep adding hello to it. Then we'll say stream.send the response, right? So create a response and then send that response. Okay, so this is your bidirectional streaming for at the server side. Really straightforward, and we need the same for the client side as well. So we'll say by stream.go, and here is where we'll create the function which our main file is waiting for. So first let's start with package main. Then we'll import a couple of things, including PB, but most importantly, we'll say func call say hello bidirectional stream. I think that's the function that this is waiting for, right? And takes in client pb.greet service client, and names, which is pb.names list. Then you have, so just like we did with all the other streamings, we'll print out at the client side that hey, bidirectional streaming has started, and you'll say client.say hello bidirectional streaming to be able to call that function, and context.background. And capture that in this variable called stream. Handle the error here itself. Could not send names. Okay, so from the client side, we want to send a stream. And we want to also receive a stream, but we're calling the function at the server side, which is say hello bidirectional streaming. This is the function, so it's a remote procedure call. Okay, so you want to send a stream and also receive a stream. Now to do all of that, we'll use channels. So we'll create a channel, and we'll create one routine first. So go func. In this go routine, we'll say stream.receive. So this is for receiving our stream from the server. Okay. Then let's handle the error. If it's not end of file, then let's handle the error. Some error while streaming, and print out the exact error here. and print out the message. Then you close wait C, which is your channel, close the channel, and this is your go routine. Okay, just a go routine for your okay, yeah, so I see this issue here is because it should be a round bracket. So now you're able to receive the stream and do something with it. You're able to print out that message. Okay, now you'll create another for loop here. So for name, and you'll range over the names, and you'll create a request, pv.hello request, and we know that the name, the hello request is basically a struct which requires name. It requires name with a capital N, and we are passing name with a small n from here, name, which is going over the names and then getting each name one by one and then creating a request object from it. And you know that we want to receive and send, so it will have to both the functions, just like our server had. It was receiving and sending, just our client is also the same. To be able to send the request to the client, it's going to have stream.send, and it's basically sending a request which is going to have names and sending it one by one. That's why we have the for loop. Okay, so if error equal to stream.send for request, handle the error here itself, log.fatal f error while sending the request. Okay, and then you know that there is a delay of 2 seconds because we want to simulate what it would look like to actually stream a lot of data. And then you'll have stream.close send, and log.printf by, sorry, it all looks out of whack, log.printf bi-directional streaming finished. All right, so there's a small typo, it should be send. Now everything looks okay. So we want to just go ahead and save our main.go also and try out the bidirectional streaming. So I'll open up my 2 terminals. I'll say go run star.go here for the server, go run start.go here for the client. Here you can see it says hello Akhil, hello Alice, and hello Bob is not showing here because we want to refresh the terminal. So it says hello Bob and bidirectional streaming finished. Okay, that's what you wanted to print. Both sides streaming is happening. So that's what you want to print in our client, and we'll stop the server also. So this is it, guys. This was the entire project. I'll just go over everything very fast quickly so that you have an idea. So we started with our main.go file for server, where we created our port and our hello server struct and our func main, which started the server. Then we have a client which is also a Golang server, which basically calls our gRPC server with the help of gRPC dial function on that particular port on which the gRPC server is running. And we usually pass our names either as a request or as a stream, right? As a regular request or a stream, which is a request. And then you have all of these functions. One is the regular Unary API function, one is the server stream function, client stream function, and bidirectional stream function, all of these functions. So we kept commenting them out to see, to demonstrate each of these functions. And for each of the functions, at the server side and at the client side, we have different files. So this really organizes our project really well. So for Unary API call, we have a very simple function on the server side and a very simple function in the client side, as you can see, right? Just sends a request and gets a response. Then we implemented server stream from our server side, where we said that the server will receive a request, okay, which was just a names list. and it'll go over those names and it'll send a stream to the client, and there'll also be a delay of 2 seconds when sending that stream. Okay, so that's why you use the stream.send function. Now in the client side for server streaming, we're just sending the names list, and we are then receiving the stream, right? So you need some logic to receive the stream and also to check that the stream has ended. So that's why there's an end of file logic here, and then you type out streaming finished. Then we implemented client streaming. For client streaming, by the way, all in between, we also created these files based on the proto file. So we created in the beginning itself the greet proto file, which is your contract for the functions, the RPC functions that will be happening. Remote procedure call basically works in the way that the client directly calls the functions at the server side. So you have to define those RPC calls. The first is the Unary, then the server client, and then the client streaming, then the bidirectional streaming. And we have defined what all they accept. So this accepts no parameters, returns a response. This accepts a name list, returns a stream. This accepts a stream, returns a message list. Then this accepts a stream, returns a stream. So all of those things also have been defined out here properly, and then we created these 2 files with that proto-c command. These 2 files were created automatically for us. So coming back to the client stream, for the client stream in our server side, we know that we have to receive a stream because the client is streaming, right? So we'll have the same logic that we had at the client side for server streaming. We'll have the stream receive, we'll have the end of file checking, we'll have the error checking, and we'll just append 2 messages and we'll just print out the stuff. That's it. At the client stream, we have the ability to send that stream to the server. So we have stream.send, and we also have a delay of 2 seconds, and we want to print out everything that we get back from the response that we get back from the server. We want to print that out here. For bidirectional streaming, we have both the ability to receive as well as send the stream to the front end. And the front end, which is the client, we have our ability to call the function. Then we created a channel, and then we had the ability to receive the stream and also to send a stream as a request. Now this means that all of the microservices, right? So if you want to have interactions between microservices, you'll be using gRPC, right? That is one way. The other way is to use Kafka. So I'll show you that also in the future. So the one way which is a remote procedure call, you create a client and a server on one microservice. Also, you create another client and server on another microservice, and then they start interacting with each other. That's how this works. Okay. Or you can just create like one client only at a microservice and just a server only at microservice. You can do that also, depending on what you're trying to implement. Okay, so this was a really great project, guys. We've built something nice, okay, here. But this demonstrates those 4 types of streaming, 4 types of RPCs. Okay, in the next project, which we'll build with gRPC, like whenever it comes out, right? Because there could be different projects that come out for Golang and Rust in between, right? So whenever the gRPC project comes out, we'll build a proper CRUD with gRPC. And then after that, there'll be a 3rd project where we'll build something more serious with the database. We'll get a database involved. So you'll also learn how to use gRPC in a microservice, but also databases. And then once you've built CRUDs, once you've built used databases and all, then it's the right time to start working with microservices. That's when the more advanced projects will start. Okay, so I hope you're getting used to gRPC now. And in the future, I also have some projects coming up with GraphQL, like a complete full-on project with GraphQL. You have a front end, you have a backend in Golang and a database, all of that stuff. Okay, so a lot of stuff coming up for Golang. So if you are not following this channel, you should, because there's going to be awesome content which you won't find on the internet. To be honest, you can't find it on Udemy, you can't find it on YouTube for sure. This content is only there on my channel for now, as of now, because if anybody had this knowledge, they would create courses, paid courses out of it. They wouldn't give it for free, right? You know how it works. You know how the industry works, right? So, but I'm giving it out for free because my priority, because I make money with something else. I have my own companies. All right. So do subscribe to this channel and share this with your friends. Share this with your friends and make sure they also learn and they also get nice jobs. That's what will make me really happy. Thank you guys. I'll see you in the next project and keep watching.